Alright, so this is going to be video 3 of integral problems with parametric equations. Okay, so we have our problem up on the board here. We need to find the area between x equals 6 times theta minus sine theta and y equals 6 times 1 minus cosine theta. Okay, and we have our interval from 0 to 2 pi. Okay, we have our formula, right? This is the formula that we use to integrate parametric equations, and we know that x equals f of t and y equals g of t. That being said, we can find f prime of t and we can find g of t. F prime of t is just going to be the derivative of this x equation, right? So we're going to get 6 times a 1 minus cosine theta. Alright? And our g of t, right, that's just going to be our y equation. So that's actually also going to be 6 times 1 minus cosine theta. Alright? Now we would put these together to get our integrand, but we also need to find our bounds before we actually plug everything into this integral. Okay, so our bounds should probably just be 0 to 2 pi, right? Well, we need to make sure first, okay, because remember with our part 1 video, if you didn't see that, definitely go check it out. We were trying to find the area of an ellipse, okay? And that was going from 0 to 2 pi. The only thing was, right, and we shortened it to be just 0 to pi over 2. We were integrating in the wrong direction, right? We were integrating left, which means we were going to get a negative answer. Okay, so we need to make sure that when we're going from 0 to 2 pi, that this thing isn't circular like that and moving counterclockwise, okay? Because then we need to end up changing this around. Okay. Now, I'll just kind of tell you the graph here. The graph looks something like this. Okay, and this is 0 and this is 2 pi. Okay, so we'd actually be integrating in the positive direction. So it is going to work out in this case, right? I'm not going to go through graphing again with you guys. You guys will be fine with that. All right, so we now know that the interval is, we can keep that as 0 to 2 pi. So we can plug that all into our integral from 0 to 2 pi. And then we can combine our 6's and take that outside the integral to get 36 out here. And then we have a 1 minus cosine of theta squared. We're going to have a d theta on the outside. Alright, so now we can just do a little bit of foiling here. Alright, and we get 1 minus 2 cosine theta plus cosine squared of theta d theta. Alright, and we can use our half angle identity here to get 36, the integral from 0 to 2 pi of 1 minus 2 cosine theta plus 1 plus cosine of 2 theta. And we'll put each one of these over 2 instead of putting the whole thing over 2. And of course we have our d theta here. Now the reason why I kind of divided that 2 up to put it over each of them individually is because we can combine this 1 and 1/2, just make it a little bit easier before we end up integrating. Alright, we end up with 3/2 minus 2 cosine theta plus cosine of 2 theta over 2 d theta. Alright, and now we're just going to integrate 36 times 3 theta over 2 minus 2 sine theta plus sine of 2 theta over 4. It's going to be evaluated from 0 to 2 pi. In doing our evaluation step, we'll think about this, alright? 0 is just going to kill off everything, right? And when we, of course you plug it in, you get sine of 0, that's 0. Sine of 2 times 0, it's still going to be sine of 0, which is 0. Okay, and when you put in that 2 pi, alright, this is going to go to 0 because sine of 2 pi is the same thing as sine of 0. And you get a sine of 4 pi here, which is also 0. So really the only thing that you need to worry about is plugging in 2 pi for this term and multiplying it by 36. Okay, so you literally get an answer of 36 times 3 times 2 pi over 2. Okay, and that, of course, the 2's cancel out, so you get 36 times 3 pi, which is going to be 108 pi. And that's your answer. Alright, so that's pretty much it, right? We were able to find our bounds. We checked that with the graph. Okay, that might be the only part that's a little bit tricky, but you'll be fine with it. Alright, and we found f prime of t. We, of course, already knew g of t. We put that in our integral, and we're set, alright? So that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for parametric and polar, the explanation video for parametric integrals, and the next video in the series. See you soon.